welcome back. So today, we're going on a journey. We're going to explore what we call the Sun-Earth connection, which is really the path that space weather takes. We're going to follow a single invisible thread as it travels all the way from the Sun, that's 93 million miles by the way, right down into the very electronics that power our entire world.
And just so you know where we are, this is the second part of a deep, 10-part dive. It's all based on a really detailed report from the folks at RFI Detectives, who are part of Virtualization Options LLC. We're essentially breaking down their findings chapter by chapter.
You know this quote right here? This is what it's all about. This is the whole reason we're here. We're going to track our story's main character, or I guess our main villain, a single high-energy particle. Its mission? To create pure digital chaos. So, let's follow its path. All right, here's our game plan. First, we'll look at the Sun's three-pronged attack. Then, we'll follow each of the three different ways that energy and matter actually get to Earth. And finally, we'll see how it all comes together to create this cascade of problems.
Okay, let's get right into it. The most important thing to get your head around is that the Sun doesn't just launch one type of attack. No, it's got a whole arsenal, a real triple threat it can unleash. And each one of those threats causes a totally different kind of problem for us back here on Earth.
So these are the three main weapons. The way I think about it is like this. Solar flares are like the blinding flash of an explosion, pure light and energy. The coronal mass ejections, or CMEs, they're the huge, slower-moving shockwave. And the solar energetic particle events, well, that's the high-speed shrapnel. Let's track each one.
First up, we've got the speedster of the group. The absolute fastest threat to leave the Sun is the solar flare. And what's wild is, it isn't made of stuff at all. It's just a wave of pure electromagnetic radiation. So, what is a solar flare, really? It's this sudden, incredibly intense blast of energy. We're talking about the whole electromagnetic spectrum here. Everything from radio waves on one end to super powerful X-rays on the other. And all of it is moving at the fastest speed possible in the universe. And because it travels at the speed of light, it gets here, well, fast. 8 minutes. That is it. There is basically zero warning. By the time our telescopes see the flare erupt on the Sun, its effects are already hitting us here on Earth.
So what does it do when it gets here? Well, this wave of radiation just slams into our upper atmosphere and basically supercharges it, particularly a layer called the D region. This newly beefed up layer starts acting like a sponge for high-frequency radio signals, causing radio blackouts. For things like aviation and ships at sea, that's a huge deal. For the rest of us, it messes with GPS, turning your typical 3-meter accuracy into a 50-meter, guessing game.
Okay, let's pivot to the second pathway. This one's not a wave of energy. Oh no, this is a storm of actual physical matter. We're talking about microscopic projectiles flying at insane speeds. And these are the particles that do the direct damage to our digital world. These guys, the solar energetic particles, or SEPs, these are the culprits from that quote at the beginning. They're basically protons and other atomic bits that get shot out from the Sun. Think of them like cosmic bullets, so energetic that they can punch right through the metal shielding on a satellite and can even affect electronics down here on the ground. And here it is. This is the heart of the problem for everything digital. When one of these little high-energy particles smacks into a microchip, it can deposit just enough electrical charge to flip a single bit of data. A 0 becomes a 1 becomes a 0. We call this a single event upset.
Right, so a single event upset, or SEU, is the most common result. It's what we call a soft error. It doesn't actually break the chip, but man, it can cause some serious mayhem. It's like a ghost in the machine, a phantom typo in your data, or a single wrong command that can crash your favorite app, or worse, silently corrupt an important file.
But it can get so much worse. A single event latch-up is where things get physical. That particle strike doesn't just flip a bit, it triggers a tiny short circuit inside the chip. That little component gets stuck in the on position and starts pulling way too much power. If you don't reboot the device, and fast, to clear that state, the overcurrent will literally cook the chip from the inside out.
And then there's the worst case scenario, a single event burnout. This is a direct hit, a catastrophic kill. A particle hits a power transistor. Think of the components in a power supply and it just fails. Instantly. Permanently. There's no rebooting from this. The hardware is just gone.
Okay, now for the third delivery system. This is the slow one, the big one. But in a lot of ways, it's the most dangerous one for our large-scale infrastructure on the ground. We're talking about the coronal mass ejection.
You know, it's hard to even imagine the scale of a CME. You're looking at a billion-ton cloud of solar plasma, and this is the important part. It's carrying its own massive, tangled magnetic field with it as it hurtles through space. The biggest threat here isn't the particles themselves, it's that giant magnetic field they bring along for the ride.
Now, unlike that 8-minute radiation flash, a CME actually gives us a bit of a heads up. Its journey can take anywhere from about 15 hours to a few days. That travel time is the crucial window that space weather forecasters use to issue alerts about possible geomagnetic storms.
This slide shows perfectly what happens. The CME's magnetic field slams into Earth's magnetic field, and our planetary shield starts to shake and vibrate. That magnetic rattling, in turn, induces powerful electric fields right here on the Earth's surface, and that electricity needs to go somewhere, so it surges into any long conductor it can find, our power lines, our pipelines, our undersea cables.
And the stakes here, they just couldn't be higher. The report brings up the famous 1859 Carrington event, the biggest solar storm ever recorded. If a storm that strong hit our totally plugged-in society today, the damage would be in the trillions of dollars. And recovery? It could take 4 to 10 years to replace the biggest, most critical transformers in our power grid.
So here's the bottom line. These three threats, they don't happen in a vacuum. A single, powerful event on the sun can unleash all three pathways. You get a complex storm of radiation, particles, and magnetic fields, all hitting us, building on each other, and creating this brutal cascade of failures.
This is the whole journey, the entire kill chain all on one slide. It starts with an event on the sun. That event travels through space and interacts with Earth's environment. That interaction produces real-world physical effects like radio blackouts or those induced currents. And those physical effects are what finally, ultimately impact your device, flipping that one bit or frying that one transformer.
So, we followed the threat all the way from the sun, right to our doorstep. We understand the physics of the attack. But that leaves us with a really big question, right? Which of your devices are the most vulnerable? Is it your phone, your car, the servers that run your entire business? And maybe more importantly, what can any of us actually do about it? Well, we'll get into all of that in part 3.